In this video, we'll introduce you the Industrial Computer Engineer Laboratory, a smart factory for applied research. Many manufacturing industries have production lines that are not monitored and may not be optimized. For these reasons, the aims of the Fourth Industrial Revolution are: increase automation of production plants, improve communication among machineries and allow self-monitoring, to reach the production of smart goods customized to customers' needs. These can be reached through complete production monitoring, dynamic plans reconfiguration, and predictive analysis. We have a completely reconfigurable production line. Our targets are the creation of a recipe by decomposing images during the 2021 and the creation of recipes by recognizing human operation during the 2022. System synthesis and verification, data and process modeling, and application compose our production line. For example, we perform verification and synthesis of discrete and hybrid systems, modeling, optimization, and controlling complex systems and robotics. We use both IoT and industrial IoT, developed our data collection architecture and digital twin. We apply collaborative robots for boosting productivity, vision technologies, and mixed reality to our production line. This is a digital representation of the laboratory. These are the machinery that collaborate, and on the left side you can see the technologies that support them. We'll see an example of production in the University of Verona ICE Laboratory, a demonstrative structure of the Industry 4.0, composed of 5 manufacturing industry areas. In the first area, we find an automatic and functional tester. In the second, we see the subtractive production under the form of a 4-axis milling machine. Finally, in the third one, we find the addicted section composed by 2 3D printers. On the bottom right of the screen, we can see the digital twin that communicates with the machinery via OPC UA protocol to monitor the state and replicate in real time. The line transports many pallets, directing them to the different areas. The line software, handled by Siemens plc, is programmed to be reconfigurable and permits to move and to track every pallet without a predefined path. The line is controllable remotely thanks to the UPC-UA protocol or with the operator panel. The assembly area will take 2 pieces to put them in one monopallet. KUKA takes the first piece. It is a collaborative robot with double torque sensor on every joint that ensures accurate contact and force detection. This feature permits not only the presence of a human operator, but also the performance of tasks with a certain degree of uncertainty and where operational sensitivity is crucial. ABB takes the second piece. It is a collaborative robot with 2 arms equipped with gripper and suction cup to collect small components thanks to compressed air. The right arm also has a camera for visual assistant tasks. A Siemens Safety plc coordinates the 2 robots, and the OPC UA interface allows it to be directly integrable with the laboratory infrastructure. The Blazer camera with a 60 fps and 2 MP resolution performs product quality control by interfacing with the edge computer. The camera takes place in a specific darkened cabin to avoid lighting noise. It also has an OPC UA server to coordination with other areas. The mobile manipulator takes pieces from the mini pallet and transfers them to the vertical storage or the waste area if the product doesn't pass the quality control. The RB Kairos robot has a role-based open-source software stack. It has a mobile base that transports a UR5 arm. It also equips a laser scanner and depth cameras to ensure operator safety. RB Kairos work independently in synergy with the mini pallet line to realize an efficient movement of the pieces. Vertimag EF is an automatic storage system. We use it to stock raw material and finished products. The pieces loading is automatic thanks to the mobile manipulator. In the ICE laboratory, there is a data collection infrastructure composed by sensors, box I/O gateway to handle multi-protocols, a data collection architecture that is based on Kubernetes containers, and the Siemens MindSphere cloud to reach data from remote. We have developed dashboards to visualize the collected data both from IoT and industrial IoT in real time or past.